Hey guys, and welcome to day number 4. In this video I will talk about some basics that are absolutely crucial to understand if you are a Fusion 360 user. I will talk about the difference between polygon meshes and solids. I will show you how to create solids, how to turn them into surfaces, and how to turn these surfaces back into solids again. I will talk about T-splines, and I will show you how Fusion handles meshes. Let's get started. Before we continue, I have prepared this chart to give you a quick overview about the different types of 3D models and geometric modeling. On the left, we can find Fusion 360. Among other CAD applications, they all work with BREPs. BREPs is short for boundary representations, which basically describes the technology behind building solids and surfaces. And solids and surfaces are also the material we are working with here. Some of the technology is the NURBS curves and NURBS surfaces, and sometimes also T-splines. And the procedure here is parametric modeling, which means that you are building 3D models using parameters. Procedural modeling, this is the complex type of modeling where you enter mathematical values and then generate these very complex 3D models automatically. And then also, for instance, direct modeling or direct editing, where you deactivate the design history and manipulate and modify the solids and surfaces on the fly. Some examples for CAD applications here are, of course, Fusion 360, Inventor. Fusion 360 was previously a part of Inventor, then SolidWorks, CATIA, Siemens NX, Rhino 3D, and Moi 3D. When you look at the right side of this chart, we have Polygonal Modeling that deals with triangle meshes and polygon meshes. They sometimes start with point clouds that you receive from 3D scanning. We have vertices here that are connected with edges and then turned into faces, and these faces are then turned into surfaces and complex models. And some procedures or approaches here are subdivision surface modeling, digital sculpting, or the traditional classic box modeling. Popular software packages are 3ds Max, Maya, Blender, ZBrush, Cinema 4D, Modo, and Lightwave. Generally speaking, everything on the left gets created with the purpose of later production, and by production I really mean to turn the drawings and designs into physical goods and technology. And many models on the right side stay in a digital environment like games or visual effects, for instance. But also keep in mind that both areas overlap each other, so you would have to turn a model that you've created in Fusion 360 into a polygonal or triangle mesh to make it 3D printable. Now keep this rough overview in mind when I show you what different types of models Fusion 360 is able to handle in the next few minutes. Let's start with solids first. I'm in the design environment here, the solid tab is open, and there are several different ways to create solids. So again, like I've mentioned before, do not focus too much on the single steps. It's totally okay if you are not able to follow them. It's more about the general concept in this video. So I start with a sketch, I pick the top plane, I hit the S key to open up the sketch shortcuts, I pick the rectangle and draw a rectangle on the top plane. Now I exit or finish the sketch and add some volume to our two-dimensional line drawing so that I can turn it into a box like so. I hit OK, and now I select the top plane of the box, go to create, and this time instead of starting with a circle, I pick a cylinder solid and draw this cylinder right on top of our box. Add some height, make sure that the operation is set to join, and then I click on OK. Now when I move over to the browser and open up this bodies folder, I have one solid body inside. And I can prove that this one is a solid by going to the Inspect drop-down menu, pick Section Analysis, choose a plane, move this plane over like so, And whenever you see this cross-hatching, it indicates that we are dealing with a solid body. So let me quickly get rid of the section analysis. And when I right-click on the body and go to the properties, I can also prove that this is a solid because we have a surface area here and we have a volume. And of course, a volume only appears when we are dealing with solid objects. Now, let's make this a little bit more interesting and turn the solid into a surface model. And for this reason, I switch over to the Surface tab. I select one of the planes of the box and hit the Delete key on the keyboard. And now we have turned the solid into an open surface model. So this means we can look inside the object, and the planes that previously comprised the solid volume are now paper thin. We have an outside and an inside. The inside gets illustrated in a yellow color and the outside is whatever your material is. And at the same time, also the icon over here in our browser has changed from the white solid box into this orange open surface. I can again prove that we are no longer dealing with a solid model by right-clicking on the body over here, go to properties, and as you can see, the volume is 0, and this means it's not a solid object anymore. And the same goes for the inspect tool, the section analysis. If I pick the plane and move the plane over, no cross-hatching appears, and this means we are dealing with a surface model. Now, a surface model is not a bad thing by any means. You have a lot of tools available to adjust the surface model, and you can eventually turn it into a solid later on. So let me try a few things here. I'm gonna select all of the faces, then I go to Create, Offset, and offset them by -4. So my goal here is to give our box with a cylinder on top a little bit of a thickness. And as you can see, I have now an outside shell and an inside shell. And like I've mentioned before, the faces are turning outwards when they have the material color, and when you look at the rear side or the back side of the faces, they have this yellow color. So when we add some thickness to the object, it makes sense that the inner body faces inwards. And so I select it, go to Modify, and reverse the normals, like so. So you probably already get an idea of what I'm trying to do here. And then I simply close this opening here by using the Loft tool. So I go to Create again, pick Loft. Then I add the first profile. I select all of these edges. I add a second profile, select the inside edges like so. Then Fusion already creates the cap for me. I click on OK, it gets added as a separate or as a third body. Then I go to Modify again, reverse the normals. And now I end up with an outside shell, with an inside shell, and with our cap. If you observe the model in this stage, it looks like a solid, so you cannot tell any difference. But when you use the section analysis again, the model remains hollow inside or in the area between our faces here. And this is because all of the components are not welded or knitted together. So I go to the Stitch tool, select all of our faces here and the outside shell. And now the green line indicates where the stitching is going to take place. And when I now click OK, the operation ends in a new solid body. So when you look at the browser here, the 3 surface component parts disappear and I end up with only one solid body. I go to the section analysis and the cross-hatching appears again. So this means that we are dealing now with a solid body that also has volume, as we can see right here. Now it's time to point out something that is absolutely fundamental to many CAD programs, and this is the parametric design history or the parametric history. And I'm talking about this little toolbar down here, and as you have probably already noticed, it gets longer and longer with each operation I perform on the model, and it actually captures everything I do. So it allows me to scroll back in time, so to speak, and to make changes on the very first sketch, for instance, or the offset that I have performed, or the stitching or the loft that I have created. So I can drag this little line back in time to the initial sketch. So let me show the sketch. As you can see, the browser now only contains a sketch. There is no body because at this stage of my creation, no solid was created. So if I move it over to the right, you can see that now the body appears because I did an extrusion. And the next step was the cylinder that I have placed on top, followed by deleting the surface. Then we had an offset. And I have reversed the normals. I have closed the gap with a loft feature. I have reversed these normals too. And last but not least, I have stitched everything together. And here you can also see that I had three surfaces before the stitching, and after the stitching I turned it into a solid body. Now you may ask what this is good for, and the cool thing is I can not only go back in time, but I can also change all of the functions and features that I have applied to the model. So for instance, if I scroll back to the offset, double click on the little icon, and I can now change the previously defined value of -4 to something like, let's say, -12. And hit OK, and when I move the slider over to the right again, everything updates accordingly. So the loft gets updated and also the stitching, and we turn the thing again into a solid body. You have to be careful with these operations because it depends on how well you have constructed the model. This starts with the initial sketch and also the features that you apply step by step. So it requires some experience to build models where you can scroll back in time, make large adjustments, and have the model updated when you move the slider over to the right again. I remember that when I became aware of this function and the workflow, I was absolutely blown away by it. Having a background in 3ds Max and ZBrush, it means that whenever a client wants me to change something, I sometimes have to rebuild the entire model. And with this feature or with this function, I can simply go back in history, make my adjustments, and have an updated model in seconds. It also comes with a slight downside though. You have to plan and you have to prepare your model and all of the steps up to the final model in a way that allows you to go back and make these adjustments. So let's see if I can demonstrate what I mean by this. And when I go back to the initial sketch and right click on the sketch and click on edit, and let's make it wider like so, and then I finish the sketch and drag the timeline over to the right, I get prompted with a bunch of warnings and error messages. It looks kind of right. We still have a solid, but something went wrong with the surface offset here. So I go back to the surface offset, double click on the feature. Here it looks okay. I got no error messages. I click OK on the dialog box and it seems to be fixed. And now I move the slider slowly to the right, watch how the model gets rebuilded, and this small adjustment already seems to fix the problem. But I'm dealing here with a very, very simple model. It gets way more complex and complicated if you are building highly complex models that consist of several different parts or surfaces. Now, before you ask, do I have to start with a sketch? Do I have to turn the solid into a surface model, make my adjustments, and convert it back into a solid model again? The answer to this question is no. It really doesn't matter where you start and how you start. Usually only the result is what matters. Of course, it depends a little bit on how many changes you expect to make once the model is created. But all in all, it doesn't really matter what kind of tools you use or what kind of workflow you use to come up with the finished model. I can, for instance, try to rebuild the same thing with a different method. So create a new document, and instead of starting with a sketch, I start with a box primitive or box solid right away. I define the top plane as my starting plane, give it some height, click OK. Then I do the same for the cylinder. I select the top plane again and create a solid cylinder on top. You could, of course, also draw a circle and extrude the circle. Now I give the whole thing some thickness, and I do this by enabling the section analysis first so that we can see what's going on in the inside. And then I click on the shell command, select the entire body and write something like 4 millimeters. Boom, there you have it. Let me hide the section view again, and all it's missing now is the opening at the front here. So I simply select this plane, create a new sketch, select the plane one more time, project the edges like so, and then I select the edges and offset them by -4. And last but not least, I push this box to the inside, click OK, and we have created the same, or at least a similar object like I have created before when I was turning the solid into a surface model and back into a solid again. When you now look at the bottom of the screen, you can see that the parametric history looks a little bit different than like what we had before, but of course the same principles are still true. When I go back to the initial object, the box, I can double click on it, change its dimensions. So let's lower the height a little bit, click OK. Then the cylinder should follow because I have placed it on the top plane of the box. The shell command is still valid, and the same also goes for the cutout of the front plane. And when I now continue to add additional features like fillets, for instance, you can see that the timeline continues to extend to the right. Now, I have shown you a lot of the basics in the last 10 minutes, but what I'm gonna show you now is really amazing, and it blew my mind when I first became aware of, and it's one of the reasons why I'm so interested in Fusion 360. And it's a function that is called direct modeling or direct editing. And this means you can adjust the model without relying on the parametric history. And this means you can delete or deactivate the design history. And this can be done when you click at the top component part and go down to do not capture design history. This option is also available in the right bottom corner right here. Do not capture design history, and when I click this, I get prompted with a warning that the timeline and all design histories will be removed. So I'm okay with this, and by doing so, the timeline disappears. I can now continue to adjust the model by simply selecting the faces. Let's say I would like to get rid of this wall here, then I simply select the inside face, activate the move command, make sure that it is set to free move, and then I offset the face and move it to the outside. And this looks like I'm going to mess up the entire area here, but as soon as I click OK, Fusion takes care of this section, it removes the wall and it cleans up the area. So this is absolutely fantastic. I can do the same thing with the entire inner section here by selecting the bottom plane and offset this plane or this face by moving it to the top, so it intersects with the geometry that we have here at the top, and when I click OK, Fusion closes the entire area. I can further adjust the dimensions or the size of certain parts, so I switch to the select face mode and select the topmost part, and then I simply move it up a little bit and click on OK, and Fusion updates the model on the fly. I can also get rid of them entirely by selecting them and simply hit delete. And when I'm in the direct editing or direct modeling mode, I can still use any of the functions that I can find here. So let's apply a shell again. I select the entire body, type in 4 millimeters, click OK. Then I select the outer face, offset it a little bit to the inside. And when I click OK to this command, I have removed the front face so that we can see the inside of the box again. When you do not have any previous experience in other CAD applications, then you might think that this behavior is standard, but I can guarantee that it's not. It makes the entire modeling process a lot more straightforward, a lot more intuitive, and it's also a huge relief when you have to deal with surface models and solids that you import from another application. In this case, the parametric history is missing, and you had a hard time making adjustments on the model. So sometimes you had to reverse engineer the entire part to make it work. But in Fusion 360, you simply grab the faces, move them around, delete them, add additional parts, and you can do all of this on the fly. Now, this is all you need to know about solids and surface models for the moment. I will also talk a lot more about direct modeling and direct editing in the upcoming videos, but for now I would like to show you 2 additional 3D models Fusion is able to handle. And the first one is the freeform or the T-spline object, and the second one is the mesh. And when I was deleting the parametric history before, I got access to 2 additional tabs at the top. So the first one is the form tab and the second one is the mesh tab. And now let me get rid of this body here, and I go to the form tab and choose, let's say I start with a simple box again. I select the top plane, where it is, here it is, and then I simply draw one of these free form boxes like so, give it some height, and then I click on OK. This little guy looks like a solid, but it's actually not. You can tell this by the different icon in the browser, and when I click on it and select the properties, you can see that I do not have any surface area or any volume. The same goes for the section analysis. It is empty inside, so there is no cross hatching, and this means it's also not a solid. At least not yet. I can turn it into a solid, but before this I would like to take advantage of some of the functions and features that are only available on form objects or T-spline objects. I do not want to go into great detail here. The most important thing is that you are aware that freeform objects exist. And as you have already seen here, there is a lot to cover. So let me quickly activate modify and simply extrude some of these faces. And one of the characteristics of these T-spline objects is that they always remain smooth. So there is always a smooth connection between the single faces. And let me try to extrude these faces here too, like so. And I hit OK, and then let's maybe try to bridge 2 faces together. So I go to the drop-down menu of the Modify tab, search for bridge. Here it is. Then I select this face and this one over here. Let's see if this works. Yes, it works perfectly. So you can create very complex organic models using freeforms and T-splines. Last but not least, you can also convert them into solids again by using the utilities here. Convert, and now I select T-spline to BREP. So BREP stands for boundary representation, which is another term for solids. I leave it at BREPs. I select the entire model. I want to create a new body, and then I click on OK. It takes a second, and here I have a new solid that is appended to the list. And when I go to the inspect section analysis again, we can see that it is a solid. And I can then perform any operations that are available for solids. Before I end this video, let's take a quick look on how Fusion handles meshes. And as you now already know, the mesh tab becomes available if you delete the parametric history. It also becomes available when you go to File and open a mesh from here. Now let me continue with the solid that I have here and turn it into a mesh. So I click on BREP to mesh. This requires me to select the solid. Fusion provides me with a preview, and then I simply click OK. When you now take a close look at your resulting mesh, you will see that it only consists of triangles. And this is because Fusion is only able to apply the functions on the modify to triangular meshes. So this means that when I perform a plane cut, for instance, I simply select the mesh and then I can move the cutting plane around. And let me show you what happens in case the mesh consists of 4-sided polygons, and for this reason I create a new document. And as long as the canvas is empty, or as long as our browser history here is empty, I do not have access to the mesh tab. And let me close this window again and open a mesh that I have prepared. And this one consists of quads. So this means that when I now go to mesh and try to perform a plane cut, I am not able to select the object anymore, and this is because it consists of four-sided polygons. But you can do something else with these type of meshes, and this function is available in the Form tab under Utilities, Convert. And here I can not only convert a T-spline into a B-rep or a B-rep into a T-spline, but also a quad mesh into T-splines. So I select this option, select the mesh, click OK, and then Fusion turns my mesh into a freeform T-spline object again. So let me quickly try to bridge a few faces here. I'm going to select these four and four faces on the other side, click OK, and then I activate Modify, select the faces in the middle, move them up a little bit, probably try to scale them down, like so. Now, again, this is only possible with meshes that consists or that are made out of four-sided polygons. Now, all in all, it looks like that we do not have that many functions available when it comes to adjust meshes in Fusion, but this is also totally understandable because it doesn't have to be one of the main strengths of this software. Alright then, that's it for this video. Thanks for watching the whole thing. I hope I was able to clear a few things up when it comes to different object types and how Fusion handles them. I think it's a good idea to talk about these basic concepts early on because we have to deal with these fundamentals throughout the entire series. Now, thumbs up if you like the content, subscribe and leave a comment in case you have any further questions. See you in the next one.